we go.
Thirty second, 30 second, 30 second, 30 second, 30 second, 30 seconds. 30 seconds. 20 seconds. 15 seconds. 10 seconds. 5, 4, 3, 2, 1, 1.
Well, normally, folks, we try to have our station identification right at the top of the show, but of course, that portion of the audio server does not want to seem to comply. My name is Bill Zam. Welcome to another exciting episode of Surrounded by Idiots. Tonight, our guest, and you know what? I forgot to ask him exactly how to pronounce his name. Okay, well, he can... Tarek, are you there?
Yes, good evening.
Good evening. How do you pronounce your name?
Tarek.
Tarek, okay. He holds a bachelor's degree and a Master of Electrical Engineering and Computer Science. He worked at IBM for 25 years in various positions. As an entrepreneur, he started and ran investment, consulting, and project integration services companies. His interests run the gamut from geology to history, astronomy to theology, and most of the sciences, including physics. His global travels have given him a deep appreciation for the mosaic of life and the culture on Earth. And he comes tonight from the opposite side of the planet. He is in Dubai. There is a 9-hour difference, I believe. It is just after 4 in the morning over there, and he got up especially early so that he could be with us, because he believes the information that he has is important enough to do that. Now, he's going to tell us about why he's on the show, and about the book that he wrote, and some of the discoveries that he has made. But before he does that, it occurred to me several months ago when we started the show that the intent has to be to inform the populace at large. That's the purpose of this show, of course. To give them the information that they need to make the decisions for themselves, their families, and their community. After several months of thought, I came to the conclusion that first, the information is out there. It is also extremely diverse and on many, many different websites on the internet. I also asked myself exactly how. How can we get people to come to us, come to one central point on the internet to begin to get that information? I believe that I have the answer to that question. In the coming weeks, we will tell you more about the super secret evil plan that we have to take over the internet as we know it. And now I'd like to bring in our guest. I'm not even going to try to pronounce your name again, so you can go ahead and introduce yourself, sir.
Hey, good morning. Good morning, good evening. Yes, Tarek Niazi. I hope my voice is clear.
It is very clear, sir.
The topic I'm going to talk about this evening is controversial, and many people are skeptic. I tried to address the planet changes through a different angle, not through history alone, or geology alone, or science alone, or I tried to put all those facts or theories to connect them together. I may have not gone very deep in each branch, but what I did, which I believe is different is I connected all those branches, all those facts, all those theories together to come up with a different view about what's happening to the planet. Increasing rates of earthquakes, climate change, global warming, which is different than climate change, in fact. When did it happen before? When could it happen again? And what sort of strategies have we human species taken to get prepared? So what I want to share this evening is such an information put together, and I leave the decision and the drill on further technicalities to you.
Okay. The name of the book that you have put out, I'm adjusting some of the parameters on the server here, is More Than 60 Minutes When Earth Stands Still. When did you write the book?
That was more than 2 years ago, actually, and at that time I decided to share such information by making it available on Amazon.com.
Mm-hmm. And earlier this week we were talking, and I believe you said that you were hesitant about doing a lot of media work as in relation to the information that you have, but given the state of the world economy, I believe you said, and some other things that are going on, you decided that you probably couldn't do much more damage than is already being done.
Yes, you see, the thing is, nobody's perfect. So in my analysis and putting all these segments together to come up with a total picture, I may have done wrong in somewhere in the total picture, to come up with a total picture. Then the consequence, as we will see, the consequence of what's going to happen will certainly impact societies, communities, economies, industries altogether. You see, there are two opposite. I hear some echo in my voice.
You're okay at this end.
Okay, there are two opposite forces that attracts attention. One is to get ready for what's going to happen and minimize the calamities and pain. And the other one is, if all these ideas are wrong, then you may have wasted or created an anxiety at people unnecessary. You may have impacted economies. You may have slowed down industries. And this prevented me from talking about the topic, announcing the topic. I just wanted to document it and share it on the internet. Mm-hmm. But I was afraid that I might be wrong and I could cause harm to people and communities. So I decided not to talk about it until recently, when I noticed that I'm not going to add much of disturbance as it is now in the financial and economical world. So I decided to go live and speak about it.
Okay. That is I think that's probably a pretty darn good decision. Those of you that are regular viewers on the show and have listened to the show and watched the show before, you know that we have many guests on that share the same views as you do. We have come to the conclusion that now is the time that we have to start speaking up, start speaking out, and get the word out to as many people as possible. Over here in the States, we have a term for some of the people that are average citizens. We call them the sheeple. They're like sheep. They just follow follow the authorities and do what they're told and ignore everything that you're seeing, ignore the earthquakes, ignore all the earth changes. It's all okay, don't worry about it. And what we're trying to do is we're trying to wake these people up. We're trying to give them the information that they are going to need in the next several months, years, to be able to survive what you and I and all of our guests and many of our listeners know is actually on the way and is happening right now.
Correct.
And I'd also, because you're the first person that we've had on the show from that area of the world, and we have had several guests on that do a lot of writing about Middle Eastern affairs and other topics of interest. I would like to, if it's possible, to get your views of how the man on the street there, the average citizen in that part of the world, views what is going on and what has been going on over there for the past year or so.
It's a difficult topic to address because you have different countries within the Middle East. Some countries are struggling with the economy.
Mm-hmm.
Some countries are gliding at I would say good speed, at good wind. The retail business is doing well. The development, whether it comes to education or training, in all types of training, is moving on. This part of the world, if you add them together, it is one of the regions that is still growing, apart from Asia Pacific, still growing and growing steadily year on year. When it comes to the political scene, yeah, there has been changes in many countries in North Africa, and these changes have brought some air, some oxygen to people on the ground. I was in Cairo 2 weeks ago, and I was surprised to find out that they have exceeded the export quota for 2011 by 9% year. So there are good signs on the road. Yet there are, of course, change is not easy. Transformation will take time. Strategies are not easy to come with, not even alone easy to execute. So I will expect that for a period of time there will be some sort of turmoil, but all in all the trend is going on the right track. That's my belief.
Mm-hmm. So you think everything's going to settle down over there? Do you think?
It could have been worse, I always say.
It could always have been worse. That is for sure. That is actually some excuse me. That is actually some very reassuring words.
That's how I see it, how I believe it. My folks, my family, my friends as well see it the same way.
Okay. Well, that is very good. And the country of Dubai. Before we get into the book, the country of Dubai. What is the what is your country like?
Well, I'm originally from Egypt. I've been in Dubai for 14 years. Dubai is one of the Emirates within United Arab Emirates. The capital is Abu Dhabi.
Mm-hmm.
The growth in economy and development has been remarkable. The pace of change has been steadily going on. There are very many healthy industries such as retail, hospitality, tourism, construction, real estate have seen the world impact as well as many other places on the planet, which brings attraction also to investors to come. When you invest in Dubai, whether you are an employer or employee, you enjoy very good infrastructure, physical information, human resources. The country rely greatly on expats in delivery of its growth plans, and is doing pretty well. I enjoy living here, actually.
Well, that's good to hear. I actually, one of my best friends, her brother, is currently living in your fine country. He was working for, I believe, a company in Saudi Arabia, and then he came over here, and now he's in Dubai working for the same company. And I also believe that one of our local universities has a branch in your country. I think it's the University of Michigan has a satellite campus over there.
Correct. I myself, over the past few years, have contributed to develop and create the Canadian University of Dubai.
Oh, okay.
Yeah.
That's excellent. It is truly becoming a very small world.
Yes, it is.
It really is.
We also originated from a very small village in Kenya some 80,000 years ago, so
yeah.
It's a cycle.
I'm sitting here and I can't believe that I'm actually talking to somebody on the opposite side of the planet, and it sounds like you're sitting right here in the room with me. It is truly amazing.
Yeah. Technology makes wonders. Sometimes they brought us glitches, and having worked in the information technology field for 25 years, if things may go wrong, they will. So let's keep our fingers crossed.
Yeah, yes. Okay, so let's get into the book now that we've all gotten to know each other, and the name of the book is the PDF file that you sent me. The people on the video side of the broadcast can see the first page of the PDF, and on the audio side, I will attempt to describe the slides before we talk about them, so the people that are listening on the radio side of the broadcast know what we're talking about. The first page says Earth Changes on it. Why did you name the book what you did?
Well, because people about, I would say, 20, 30 years ago came back with this slogan, climate change.
Right.
Later on, global warming. And I think it's more than, I believe, I know it's more than a climate change. It's more than global warming. It is changes to many aspects of the planet and life on it. So that's why I call it Earth, not climate, not weather. Changes.
Okay. That's an excellent answer. I am impressed. The first slide is titled Earthquakes, and it looks like it is a history of increasing magnitude earthquakes.
Correct. If you look at the first slide, there are three sections of it. One is counting the number of earthquakes with magnitude above 6.99. Every 38 years, this number is increasing, sometimes tripled, quadrupled, doubled. So from 12 earthquakes before the beginning of the 20th century to 53 in the first 30 years of the 20th century, to 71 in the following 38 years, to 164 up to March last year. And if you look deeper, you'll find that the counting the all magnitude type of earthquakes, starting from 73 until 2006, you have jumped from 5,000 earthquakes per annum all the way to 30,000 earthquakes per annum, and I'm counting all magnitudes. Of course, the number of instruments, sensors, have increased, but to grow sixfold in a period of 33 years is mind-boggling. And then if you look deeper onto magnitude only above 6 Richter, in the same period, in the same 36 period, you'll find that you have moved from 2 to 3 above 6 Richter earthquakes per annum, all the way to 50. So you're talking about phenomenal, alarming increase in number of earthquakes, total number and above 6 Richter altogether. And the source of this data is USGS. So this data is available on the internet.
And the viewers on the video side can see the website address. It's earthquake.usgs.gov. And the subdirectories are /earthquakes with an S /world/historical.php, for those of you that are listening on the audio stream. Now I'm looking at this range of earthquakes, the above magnitude 6, and I'm seeing a couple of years where there was a significant drop in the number of earthquakes, and that would be, let me see here, that would be 2006 and 2008. Is there any clue as to why?
The counting rules differ from one year to the other.
Really?
If, for instance, you take 2010, you'll find that aftershocks are not included, even if they happen 2-3 days after the main quake, even if they are of the same magnitude, whereas in previous years they were counted. So the counting rules are not consistent year on year. I don't have, unfortunately, access to exact apple-to-apple counting, but what I try to put here is not exactly the true number, the actual number, but the trend.
Okay.
And the trend is very vivid, that it is growing alarmingly fast.
Yes, it is. I'm looking at it, and it is quite, I mean, it's very, very disturbing. I was looking at this at the PDF when you originally sent it to me, and I thought this one particular slide was quite telling. I mean, it's amazing how the growth of the number of earthquakes has increased so dramatically.
True. If we move to the next slide.
Okay, there we go. We are now looking at a slide that is called the Magnetic and Geopole, and it is a map, and it has the axis of the magnetic pole, the axis of the rotation, and several other items on there. And the question at the bottom is, why is the ice cap located over the North Pole and not at a right angle to the orbit?
If I move into this slide, I'd like to explain that Earth rotating about its axis at 23 degrees from the right angle to the orbit. Many people, I myself included, a few years back, did not know that the axis of the magnetic pole is not aligned with the axis of rotation. And there is an axis gap between the magnetic pole and the geographical pole of 11 degrees. And then I found out that this 11 degree is not constant. While the rotation, the tilt is 23 degree and is constant, the magnetic pole is wandering and has kept wandering. So this 11 degree shift from the rotation axis is variable. What I also found out is that up in the north, I'm talking about geographical north, there exists the south magnetic pole, not the north magnetic pole. It may not look of importance to audience, but if it were the north magnetic pole up there, the sun would have shined, we will see later, from the west, not the east. So it is determining the pole in the geographical north, whether it's north or south magnetic pole, makes a difference in the way the Earth rotates about its axis, whether sometimes clockwise and sometimes anti-clockwise, as the current situation.
So you're saying that at one point the Earth rotated in the opposite direction?
Yes, and I will reach out for the proof how this could happen. That what also attracted my attention is that the ice cap is not situated over the geographical North Pole. The ice cap is very well situated over the magnetic pole. And this attracted my attention. Could there be a relation between the temperature on the planet and the magnetic strength?
Mm-hmm.
If we move to the next slide, and please stop me if you have any question while I'm going through.
One point, and I hope I'm not jumping ahead in the discussion. And we actually had this part of this discussion with our science producer Boris Artemenko, who was on last Saturday. We are seeing obviously the magnetic North Pole moving dramatic distances. It is moving, it looks like, in the direction of Europe, and this year Europe is having a devastatingly cold winter. And here on the other side of the planet, where we usually have also very, very cold winters, typically right now where I am at in southeastern Michigan, it is around 0 degrees. And today it was approximately 40 degrees warmer than that. And it has been all winter. So we are having an extremely warm winter, while they're having an extremely cold winter over there. Do you believe there is a relationship to that?
Yes, I'll come to that in 3-4 pages to come, and I'll explain why is this happening and how is it. But you're right. I found out that the temperature distribution on the planet is very much associated with the magnetic field strength. And of course, the magnetic field strength is very much associated with the location of the magnetic pole. So as it quadrupled its move from Canada towards Siberia, the whole magnetic map has tilted along, and this has shifted all the temperature on the planet. Is what we name climate shift or climate change.
Okay, this slide, for those of you listening on the audio side, is called Magnetic Pole is on the Move. And I'm going to read what's on the slide here before we get into it. In the past 7,000 years, the magnetic pole kept wandering around the geographic North Pole. The magnetic pole is moving away from Canada towards Siberia, currently at 4 times faster than it used to move before. The Earth magnetic field has weakened by 10% over the past 150 years. During the same period, the magnetic pole, up in the north, has wandered about 1,100 kilometers, or 685 miles, into the Arctic Circle. And what I will do is go over here to the right and zoom in on the map of the northern part of the globe that you have on here while we talk about this slide.
You say up in the north we have the south magnetic pole, and funny enough, while it was it, and it still is, wandering from side to side, it has never coincided with the geographical pole. And this, a couple of years back, have made me wonder, why is that? And finally, I found out the reason, and I'll explain it later. But the point is, our magnetic field is not stable, neither in intensity nor in geography. And we are also blessed to have this phenomena, because it helps to change life on the planet, hopefully to a better situation, as we will see later.
And I believe the on this map, if I'm looking at this correctly, the orange on there is the oceans and the white are the land masses?
Correct. This is looking from the top, where you can see Canada, Greenland, Siberia, Asia. So this is as if you're coming from the top of the rotation axis.
Okay. All right. And obviously the little red dots on there are in fact positions that the magnetic North Pole have been in.
Correct.
And which I would suspect that the one that is at the top of the center circle there is actually the close to the current position, the one that I'm circling on the screen right now.
This picture is a little bit outdated.
Okay.
As you rightly said, in the middle there is a cross on which it is written GP, the geographic pole. The magnetic pole, as you tell, is in this picture is looking closer to Canada. But as we speak, it's moving towards to the east, to the east, and at the moment, yes, it has increased its speed dramatically. But also, what scientists have found, which is they cannot explain, is the magnetic field intensity have dropped by 5% in the last 30 years. But if we took the past 150 years, it has dropped by 10% altogether. They don't know why, and I will try to address this point. Okay. Why is the magnetic field dropping in its intensity, and why is it moving towards Siberia? And will it stop at some point, and where that point be?
Okay, let's move on to the next slide, which is entitled The Ice Cap. And this slide reads, the ice cap melts at the side where the magnetic pole is moving from, Canada, and forms where the magnetic pole is moving towards, which is Siberia. Should we cry that the ice cap is melting, or should we better announce that the ice cap is shifting? Look at the size of the ice inside the area circled in red. Now, I'm going to zoom in on that so that the folks on the video stream can see this a lot better. There are two maps here. One is labeled 1979 and the other one is labeled 1973. And the 1979 and 2003, excuse me. And you can certainly see the dramatic difference between the ice caps.
Of course, ice would melt. We all know this. Mm-hmm. But it melts into water, then water evaporates, it comes back as rain, and if it's the right temperature, it starts to form ice where the rain has fallen. So in that slide, over a period of 24 years, 25 years, you will see that the ice had melted from the Canadian side. But you also notice that it is building up on the Siberian side. So is there a relation between the shifting of the magnetic field of, of course manifested by the move of the magnetic pole, and the temperature on the planet, so that temperature variation would help to build ice where it is cold and would melt ice where it is warm or hot. And so my question at this point in time, again, the relation between the magnetic field and the temperature on the planet, and we will see later what makes the ice cap shift.
And by the temperature relationship, do you mean the strength of the magnetic field, or do you mean the position of it?
Both, actually, because here we are having two syndromes here. We are having weakening of the field, and I will explain this leads to global warming. But you also have shifting of the whole magnetic field, and this makes some warm places to become cold and some cold places to become warmer, as you rightly hinted 10 minutes ago when you mentioned that Europe is going through a temperature, a very cold temperature this year, and US is experiencing the opposite, especially in the southern states.
Yes. Yes, especially even here in the Midwest. This is substantially different than the usual El Nino type of winter. It has a distinctly different feel to it, as far as both the temperatures and the precipitation, the wind direction, the rotation of the jet stream is just all wrong. It's really disturbing and very different.
Don't worry, Bill, there is an explanation for all this. I'm coming to it.
Okay.
The most important thing would be how would we get prepared for what's coming up.
Yes, that is critically important, I believe. And,
if we move to the next slide, this slide we all know, it speaks of the temperature belts. And the temperature belts are zones of terrain or zones of the planet where we have distinct weather situation and temperature precipitation map as well. So we have the tropical belt, dry climates, middle latitude belt, continental belt, cold polar belt. We have 5 distinct temperature belts in which there are variations of weather and life. Now, are these temperature belts fixed? Of course not. If we move to the next slide, it depends where the planet, as we know, is tilted by 23 degrees. So that's why we have 4 seasons, where in December the daylight in the south is longer than the night. In June, for instance, it's the opposite. The daylight in the north is longer than night. And March and September, we have equal day and night across the globe because of this 23-degree tilt. But not only that, the temperature belts in this case will vary, will expand. The more daylight we have, the more expansion of the temperature belts, whether in north and south, and vice versa. Why I'm saying this is because if we move to the next slide, and this is my question, I place the planet at 23 degrees opposite to the sun, and I try to compare the tropical belt temperature versus dry climate temperature. And I'm taking an example. I say on December 21st, the sun radiation, or radiation in general, is perpendicular at right angle to the Tropic of Capricorn. The daylight is longer at the Tropic of Capricorn than the tropical belt, the equator. Yet the temperature at the Tropic of Capricorn is less than the temperature at the tropical belt. And I'm asking, why is that?
That is
There's also another question I place, which is at the tropical belt, at the equator, the temperature is much higher than middle latitude belt down in the south, in southern than Johannesburg, for instance. And again, the question is, if the radiation projection at the tropic is the same as the middle latitude belt, why we have so much difference in temperature? Go ahead. Sorry, I cut you.
No, that's a very good question. That is I mean, it's an obvious observation, but I've never actually taken the time to make that observation. And has that been true for the entire time that we've measured those temperatures, or is that a recent phenomenon?
No, it is the entire time, but normal people will think that temperature is related to how far is the specific terrain from the sun.
Mm-hmm.
But this is not true. If we consider that the planet is tilted at 23 degrees, the dry climate, the Tropic of Capricorn, on December 21st, for instance, is at closer distance from the sun and receiving the radiation at right angle and having a longer daylight, yet the temperature has always been lower than at the tropical belt. And this makes me ask the question, so how and why the temperature distribution on the planet the way it is? And if I move to the following slide, which I call sun's emission.
Okay, we're moving on to that one. It is called the sun's emission. The sun emits radiation such as X-rays, ultraviolet, visible light, infrared, and radio waves. The sun also emits charged particles such as electrons and protons. Electrons get trapped in the outer magnetic field, and the protons get trapped in the inner magnetic field. Our regular viewers will note that this is very similar to some of the subjects that we have talked about on the show before.
Yeah, the temperature at the surface of the sun is normally 600 degrees Celsius. That's what scientists are saying.
Mm-hmm.
But sometimes it reaches 2 million.
Wow.
Especially when you have coronal mass ejection. We are privileged and lucky to have a magnetic field to shield against those charged particles coming from the sun. Electrons are lighter than protons. We know the proton is 18-20 times the electron mass. So electrons are lighter. They are trapped within the magnetic field at higher altitude. Protons are heavier. They keep coming through until the magnetic field at lower altitude manage to trap them, creating what is known as Van Allen belts, and this was defined a century ago, almost a century ago. While the electrons are trapped in the higher altitude, we call it outer radiation belt. The protons are trapped in the lower latitude, and we call it inner radiation belt. But how do protons behave when they get trapped? That's the next slide.
And we will go down to the next slide. Let me reduce the magnification there. And this slide is entitled Protons Swing and Collide with Oxygen and Nitrogen. Is that nitrogen or nitrogen oxide?
Correct. Oxygen and nitrogen, correct. Okay. You see, if I pick up a plane from Dubai towards New York, for instance,
mm-hmm.
the plane travels in what we called a troposphere. troposphere, as we know, is 17 kilometers deep. It's the first layer of the atmosphere, and every kilometer is about 0.6 miles. 0.6 mile, yeah. Every kilometer the plane picks an altitude, the temperature drops by 6 degrees. So by the time it reaches 10 kilometer high in the sky, this means the temperature has dropped by almost 60 degrees Celsius. Then after 17 kilometers, there is the second layer of the atmosphere, what we call stratosphere. There we have the ozone. There most of radio waves get reflected, and it's getting very, very cold out there. The final and last layer of the atmosphere, which extends from 100 kilometers above our heads all the way to 800 kilometers, and excuse me for using the kilometer signs here.
That's okay.
So from 100 to 800 kilometers is called thermosphere. And I was very much surprised to learn that the temperature at the thermosphere ranges from plus 500 degrees Celsius to plus 2000 degrees Celsius. And I said, why is that?
How is that possible?
Yeah, we have a heater above our head, in fact. And I found out at again, through the internet and the many books about it, that when these protons are trapped by the magnetic field, they don't sit still. They run. They run from pole to pole along the magnetic lines. Of course, they don't run at a fixed speed. In the middle between the two poles, where the magnetic field intensity is lower, they run fast. At the poles where they slow down, make a U-turn, and head back, they run slower. And the chances, while they're doing this go and fro, back and forth, that they collide with the molecules of the atmosphere, oxygen and nitrogen. And this collision generates radiation and makes it hot out there.
Okay.
And then I was wondering, the temperature that we feel on the surface is caused by radiation reflecting from the surface, reaching us from the sky, what they call albedo, and reflecting on us. This radiation, is it coming from the sun, which is 150 million kilometers away, or is it coming from the thermosphere above our head, 100 kilometers away? You do a simple math. You just divide the temperature of the sun, let's take 2 million, the maximum, and divide by 150 million kilometers. So 2 divided by 150 is 1 over 75. And then do the same on the thermosphere. 2000 degrees divided by 100 kilometers is 20. So which is bigger, 20 or 1 over 75?
Interesting.
So which feels hotter, 2000 degrees at 100 kilometers above our heads, or 2 million degrees at 150 million away from the planet?
Well, if I had to hazard a guess, I would say it would feel hotter at the 2000 degree point, because there is actually atmosphere in there.
That's true. And this made me believe that the magnetic field not only is protecting us from electrons and protons, but at the same time is giving us warmth. If we didn't have a magnetic field, it would have been a very, very cold planet. because the radiation reaching us from the sun is 1,500 times weaker than the one reaching us from the thermosphere.
Interesting.
If I move then to slide number 10, then I summarize the last few pages or the last few slides into where is global warming coming from and what do we mean by climate change and what drives it.
Okay. I will let you go ahead and read that.
Okay. I start by saying when it comes to global warming, it's a fact that the magnetic field has weakened by 5% in the past 30 years and 10% in the past 150 years. It's a fact that when the magnetic field gets weaker, the protons will move faster. I explained earlier that protons move from pole to pole and their speed varies. In the middle, they move at higher speeds. At the poles where they slow down, stop, make U-turn, they move at slower speed. So the chances is when there is a collision between protons and the molecules of the air, higher speed will generate more heat. That's why the temperature is 2000, let's say, above Congo, and is 500 degrees above the Arctic Circle. My point is, the protons move faster on weaker magnetic field. So if the total field has weakened in the past 30 years or past 150 years, protons are moving faster than 30 years ago or than 150 years ago, meaning accidents will generate higher radiation, meaning you will have increase in the average temperature on the planet. And this is global warming. So global warming, in my theory, findings, is not a result of increased CO2 or carbon gases. It is actually a result of weakening of the magnetic field.
Interesting. So it's allowing more of the solar radiation to reach the surface of the Earth.
In that case, it's not really solar radiation reaching the surface of the Earth. It's thermosphere radiation that is increasing. Solar radiation remains the same.
Okay.
The amount of electrons and protons remain the same. But when protons get trapped and they move faster than before, the thermosphere radiation will increase and will be more than 30 or 150 years ago. Accordingly, we receive more radiation from thermosphere and the temperature grows higher.
Sort of a heating radiator.
Yes.
Like I want to say an infrared heater, reflected heat. Is that right? It's reflecting more heat down to the surface of the planet.
Yes, and this more heat again is reaching us from 100 kilometers above.
Okay, and that is due to the weakening magnetic field.
Yes, if the magnetic field, let's take the other way, is getting stronger, the protons will be slower than before. And accordingly, any accidents they make, any collision they make with oxygen or nitrogen, will generate less energy, less radiation, and the planet will be cooler on the surface.
Mm-hmm.
So my point is very simple. The stronger magnetic field, the cooler the planet becomes. The weaker magnetic field, the hotter the planet becomes. But at the same point, we have climate change. If the magnetic pole is moving from Canada towards Siberia, the whole magnetic field is tilting along. So if we say that the temperature in the thermosphere up there is 2,000 degrees in midpoint between the two magnetic poles and 500 degrees on each magnetic pole or so, and these magnetic poles are shifting, the midpoint is also shifting. So in the past, these 2,000 degrees used to lie on top of, let's say, Congo or Venezuela, what have you. Now, if the whole magnetic field is tilted, this 2,000 degrees is moving up north for, let's say, from Central America. And then the opposite side is going south. So the whole map of the magnetic field is tilting along with its temperature. And this explains why Europe is getting colder, and in the other side of the planet, as you rightly said, Central America or southern states are getting warmer. The whole magnetic map above our heads, along with the thermosphere temperature, is tilting.
Interesting. That is pretty disturbing. And this is a natural event, isn't it?
I'll explain why is it happening. Yes, I'll try to explain why is it happening. But you're right. This will lead to change temperature, but not only that. The whole meteorological map and precipitation map of the planet change.
Mm-hmm.
So we will have droughts, we will have floods at the same time, but in different places than we used to have before. Of course, melting of the ice caps is generating more water in the air. Accordingly, precipitation is becoming more, whether it is snowing or typical rain. And at the same time, we have different spots of the planet where it is getting less. Of course, the weather on the troposphere is controlled by other phenomena, and basically pressures, drops in pressure would create wind. Wind now is carrying water more than before, so gale winds would be more devastating. Cyclones and the likes, hurricanes would be more devastating than before.
That's also very disturbing. We are getting some, just to interrupt you for a second, we are getting some information from the production staff that there are some apparently internet glitches going on tonight. I imagine that you can still hear me pretty well, but your voice is breaking up slightly, and apparently some of our viewers are having a few issues watching the show, so I'm just going to sit here and blather for a second or so, and hopefully all of the issues will straighten themselves out. We, according to all of our data, we have a fairly good internet connection between our guest and myself, according to Skype. The internet rating tonight is down to 70 here in North America, so that could be causing an issue, as obviously the solar energy begins going over the part of the world where he is, and that will have an effect on some aspects of the internet. So let's see if the audio connection is back up to snuff, And we will continue on with the next slide that says the inner Earth layers are also bulged.
Yes, now that I have established the relation between the magnetic field and the temperature distribution on the planet, now I'll try to explain what makes the planet rotate about its axis. Rotation about the sun is fixed, and it is governed by the pull of the sun and the centrifugal force. So the solar year is a solar year. But what makes the planet rotate about its axis? If you look at scientists, they tell you that in many sites it had started to rotate about its axis at the time it was pulled together. They call it accretion theory. And it will keep spinning about its axis until something stops it. Yet, the rotation is not constant. There are milliseconds of variation every day. For the past 400 years, a track is kept with the speed of rotation, and sometimes it speeds up by 1 or 2 milliseconds, sometimes it slows by 1 or 2 milliseconds. Nobody can explain this, and scientists are saying this is due to the configuration of the solar system and the gravitational pull of different planets in different orbits to our planet. My theory is completely different, and let me explain. Due to the Earth spinning about its axis, the crust is bulged at the equatorial level. Why is that? Because particles at equatorial level are moving at higher speed than particles at geographical poles. Geographical poles particles of the crust are not moving at all. And opposite to the particles at the geographic equatorial level. Now I'm very sensitive about saying whether it is magnetic equatorial level or geographic equatorial level, because there is a difference and they don't overlap. As we saw before, the whole magnetic map plays with the temperature. So I thought about if particles moving at higher speed are trying to escape and the gravitational pull is pulling it back, this explains the bulge, and everybody knows this. So on the crust, the major axis of the planet is longer by 43 kilometers than pole to pole. But what about the inner geolayers of the planet? Inside the planet, we have outer mantle, outer core, inner core. According to the table on this slide, the density of those layers are different. The distance of those layers from the center of the planet is different, of course. But my question was, if particles rotating at orbital level cause a bulge on the crust, would particles rotating at equatorial level inside the planet would also cause the layers to be bulged? And what is the formula that controlled the bulge degree? The formula is very simple. Is force equals mass times square of the angular velocity times the distance from the center of the planet. Now, angular velocity is how many rotations do I have in a certain period of time. And funny enough, if you look at a particle on the crust, it rotates one full cycle in 24 hours. But also, particles on the inner core is rotating one full cycle in 24 hours. So the angular velocity of particles along one axis of the planet are rotating at the same angular velocity. However, the radius of the crust is almost double that of the inner core. So we expect the degree of bulge to be more acute on the crust than it is in the inner core. But let's not forget that the mass is different. The mass of the inner core is almost 4 to 6 times denser than the crust. So if we apply the formula, force equal mass time square of the angular velocity time distance from the center, we'll find that the force on the inner circle, which is viscous liquid of molten iron, cobalt, nickel, we'll find that the degree of bulge on the inner core is almost triple the degree of bulge on the outer core. So when you open the planet inside out, you'll find that the layers inside are not complete symmetric spheres. They are oblate type of sphere. And this is very important to the rotation of the planet, as we will see later.
So if I'm understanding you correctly, the stresses on the inner core are 3 times what they are at the crust level?
At the equatorial level, yes. If particles at equatorial level in the outer core is moving at a speed, trying to escape the gravity, and the gravity is pulling it back, the force on those outer core particles are double to triple the force on the crust particles at the same equatorial level. So the degree of bulge of the outer core is higher than the degree of bulge on the crust level.
And this would also cause heating too, wouldn't it? Wouldn't it cause a certain degree of frictional heating?
Well, the whole planet, I mean, the inner core under tremendous pressure and heat. But my point is it spherical in shape or oblate? And my theory is that it is not spherical. The outer core, which lies on a mean depth of 3,000 to 5,000 kilometers below our feet, is 4 to 6 times denser than the crust. Then its particle along the equatorial level will push harder than the crust, and accordingly will end up by having a shape of the outer core that is not spherical, but that is oblate, as we have on the crust. The crust is not spherical, it is oblate, but the degree is very small. As I mentioned earlier, the major axis, the equatorial axis, is only 43 kilometers longer than the axis which connects the two geographical poles.
Okay, I believe I have I grasp what you're saying. That is I'm trying to think from the average listener's point of view and trying to ask the types of questions that they are going to be thinking to themselves. They aren't asking any questions. They're very quiet. So apparently we are in fact getting the information across to them in a good manner.
I'll try not to make it complex. There are too many information to share. I'm excited about it, but also if I need to drill down deeper, please stop me.
No. You're doing. I can follow along. I'm sure that you see on the stream that I am pointing out what you're talking about and adding some illustrations with my whiteboard function to what you're talking about, so that the viewers can follow along. And is it time to move to the next slide? Are we
yes.
we done with this one? Okay.
Now, scientists are saying that the magnetic field that we sense on the surface is induced. What does it mean? They say that the inner core is an isotope. We all know that. The size is of the inner core is about 0.7 the size of the moon. It is under extreme pressure and temperature. But it keeps, since it is an isotope, it keeps emitting electrons. Now, scientists are saying that these electrons, when they swim in the outer core, which, as we said earlier, is a viscous liquid, they appear to be moving in helical path. And we all know that if there is an electric current moving in a circle, you get magnetic fields perpendicular to the path of the electrons. So scientists are saying these magnetic forces perpendicular to the path of the electrons are working together to get the magnetic field that we observe on the surface of the Earth.
Okay.
I'm saying this is wrong. Now, this is a very blunt statement. I have to back it up. There are two reasons to support my view. In the 18th century, there was a scientist called Coriolis. He said that objects moving in a rotating fluid appear to veer to the right in the northern hemisphere and to the left in the southern hemisphere. So if I have electrons emitted by the inner core swimming in the outer core, in the upper half of the outer core, I should expect the electrons to veer anticlockwise, and in the lower half I should expect electrons to veer clockwise. It's like when you go to New York and you fill the tub with water and then you observe the vortex as the water sinks through.
Right.
Than in Johannesburg, for instance. The whirlpool, the vortex direction is different. Same thing applies on the electrons swimming in the outer core. So if the motion is different, the magnetic fields in the upper and lower halves will be different, then we expect to observe two magnetic fields on the surface of the planet. But we don't. We only observe one field. Am I right?
Interesting. Yes. Just to interrupt you for a second, we're getting Skype is giving us some warnings that our internet connection is very slow right now. So there's a little bit of audio breakup. To give it time to speed up again, our very first guest that we had on the show, his name is Cliff High, and he is a linguist, and he does a lot of work with internet linguistic sciences, and he is a big proponent of the expanding Earth theory, and everything that you've just talked about, he agree. From what I understand what you're saying, he is he's saying the exact same thing. and he's come up with that on his own too. So that is I mean, that's it's not scientific confirmation, but there is somebody out there that does agree with you.
Great to hear it. If the speed of the internet is fine, so let me continue. The second reason why I believe scientists, sometimes, or most scientists are wrong when they claim that the magnetic field that we observe is induced by the swimming electrons inside the outer core.
Okay.
Since I proved that the outer core is oblate, meaning its major axis, equatorial axis, is longer than it is vertical axis or rotational axis, then it is common sense, it's natural. Electrons would prefer to swim along the major axis. So most of the electrons will be crowding along the equatorial level. And this makes them move, still in helical shape, in helical path, but these paths will be at right angle to the rotation axis. And this is very important. If these paths are at right angle to the rotation axis, and we remember that magnetic field is induced at right angle to the path, so the magnetic field will be parallel to the rotation axis. And the summation of all these magnetic lines would be centered around the rotation axis. So if the magnetic field that we observe on the surface of the Earth is coming from such an induced magnetic field, we would expect that the magnetic and geopole will coincide. And this has never happened at any point in time, according to the scientific measurements. Why do we have an axis gap between the magnetic axis and rotation axis? Why do we have wandering magnetic pole? If it is induced by moving electrons, then it will always be fixed in orientation.
But it is not, and obviously something is causing it to move.
Yes. So I'm moving to the next slide to explain that our planet, in fact, had a 3-magnet configuration inside. 2 electric current induced magnets that oppose each other. As we discussed in the previous slide, the electrons swimming in the outer core, moving in helical path that is at right angle to the rotation, produces 2 fields opposite to each other. It's as if we have 2 magnets in the outer core. But these are not true magnets. It's like what we say on the internet, virtual magnets. But we have a permanent magnet that we observe wandering, observe its pole wandering about on the surface of the planet. So where is this permanent magnet coming from? The only place where is it coming from as a permanent magnet is the inner core. Now, the configuration of 3 magnets, as you see on the drawing, would prevent the inner core to be aligned on the rotation axis, to be aligned with the 2 electrically induced magnets, for a simple reason. These electrically induced magnets opposite to each other have, like any bipolar magnet, have north and south. And since they are opposite to one another, the north pole is facing each other. In the middle, of the North Pole, you have the inner core with its North and South Pole. So you can imagine there are some green arrows. North and South will attract each other. North and North will repel each other. This will prevent the inner core magnet, the magnet, to ever align with the two induced magnets. And in fact, these two forces working together will push the inner core against the rotating outer core. And this push will keep it rotating along with the outer core. So the inner core rotates as a result of being pushed against the outer core.
So essentially,
but what makes the outer core moves, we'll come to that.
So it's essentially a big electric motor.
Yes, exactly. Correct.
Okay.
Very simple. You know, scientists have been wondering why Mercury, for instance, has a magnetic field, whereas it doesn't have an outer core. It doesn't have induced magnetic. So where is it coming from? Well, obviously it's coming from the inner core. On Mercury, there's no outer core. There's an inner core and mantle immediately. So the answer is simple. Induced magnets on planet Earth are not that strong. They are weak. We don't observe them on the surface of the planet, but we see the impact of them being there. They will prevent the inner core to ever align with the rotation axis.
That's very interesting. That's the first time I've heard that. So I'm wrapping my brain around it while you are speaking. That is very interesting. So if I can see if I can grasp this, we know that when you have two magnets and you have the opposite poles towards each other, they're going to have a tendency to repel each other.
Correct.
And that is what is happening inside the Earth.
Yes. Let me drill a little bit.
Okay.
You see two induced magnets.
Mm-hmm.
Okay. If I take the lower one, its north pole is pointing to the north, facing the north pole of the inner core. This is producing actually a push or repelling force, pushing the inner core up, right?
Right.
The two ends will never align with one another. Okay?
Okay.
If I look at the upper half of the configuration, again, I have an induced magnet with its north pole to the south, facing the S pole of the inner core. North and south will attract one another, pushing the inner core again up. So these two forces working on the same direction on the inner core will push the inner core against the outer core. The outer core is not still, it is rotating. So when the inner core is pushed against it, the outer core responds back. For every action there is an opposite reaction. So it pushes back. When it is pushed back, again, the repelling force will reject it. So you will have a vibrating inner core, up and down, or left and right, left and right. And this vibration will make it, will produce a friction between the inner and outer core. And this friction is important, as you rightfully said, to make the inner core rotate along with the outer core. You have a dynamo here.
So it does work exactly like a electric motor.
We will find it is working exactly like an electric motor. At this point in time, this three-magnet configuration, as I mentioned, is important to keep the inner core rotating along with the planet. Okay, to keep the inner core not only rotating, but free to swivel and tilt, but never to align with the rotation axis, never.
Okay.
My question here is, what makes then the inner core tilt, or the magnetic field getting weaker? I'll move to the next slide, and I remind the audience and your kind self on the Lorentz force. We studied this at high school. It says that if you have an electric current moving in a magnetic field, you'll get a force, simply. And it's called the left-hand rule, and it is the rule that makes motors work, or under which motors are functioning. Okay?
Mm-hmm.
Any question here?
No, that is that's basic high school science.
Now the force is proportionate to the strength of the electric current,
mm-hmm.
the strength of the magnetic field, and the angle that exists between the magnetic current and the magnetic field. And of course, that force is perpendicular. It is at right angle to the plane of the magnetic and electric currents.
Okay, this is exactly the same way that electric motors work.
Yes. Which leads us to this very interesting slide.
Let me go down
if
to
we
next slide.
Remember, slide 15.
Okay, we are there, slide 16. The Earth's spin follows the Lorentz principle.
Okay, so 16, you're right. At the heart of the planet, we have the inner core. And as we mentioned earlier, it emits electrons. It has been emitting electrons, and it will keep, scientists estimate, it will keep emitting electrons for the next billion years. Of course, it will get weaker and again. Now, these electrons swimming in the outer core, out of the inner core, are negatively charged. Electrons are, by default, carry negative charges. And there is a rule in the electricity that says the current direction is opposite to the electron direction. In any electric circuit, if electrons are moving right to left, means there is a current left to right. Very simple.
Mm-hmm.
So electrons coming out of the inner core means electric current moving towards the inner core. So these blue arrows determine the direction of the electric current. You remember we said electrons prefer to swim along the major axis of the outer core, viscous liquid.
Right.
So this means there's electric current moving from outside inside at the equatorial level. Then we have magnetic fields. Magnetic field, the strong one, the one that is emerging from inner core. And this magnetic field, of course, applies to all the geo layers of the planet, as well as outside on the atmosphere and beyond. But these red lines are parallel to the magnetic axis, which, as we said earlier, has 11-degree difference with the rotation axis. Now, remember the left-hand Lorentz principle? We have an electric current, we have a magnetic field, then on every point on the outer core circumference, we have force. This force resulting along the perimeter of outer core and inner mantle oblige the planet to spin.
So that is where the actual motor effect is occurring. It's right along where I'm drawing this yellow line right there. You can see these little black arrows there. That's what causes the planet to spin.
Yes.
That is, that's a very simple concept.
It's a simple planet, and it's a beautiful design.
It is. That is amazing. And our production staff says you are doing an excellent job of explaining it all in detail and understandable for everybody that is watching the show.
Thank you for that. Then the question becomes, if such a force makes the planet rotate about its axis, can it also explain why at sometimes it speeds up and sometimes it slows down? Yes. If we look at the next slide, slide 17, and I put 4 scenarios. The one on the left-hand side, it says this is the current situation where the day is 24 hours. There is an angle between the magnetic field and the electric current. Electric current is always fixed in direction, but the magnetic axis is moving, is tilting, is wandering, right?
Yes.
So the second scenario, what if this inner core, the magnet, is tilting and the magnetic axis is tilting along? The angle between the magnetic axis and the electric current becomes smaller. This will produce smaller Lorentz force, and the planet will slow down. If such a tilt is considerable, the day could be 30 hours, or the hour. If you split the day in 24 hours, the hour will be more than 60 minutes. If such a magnetic core keep tilting so that the magnetic axis and the electric current coincide, you'll have no force. Remember, Lorentz force is the electric current multiplied by the magnetic field force times the angle in between. If the angle between is 0, you have no Lorentz force. I'm trying to make it simple. If the inner core tilts further and the magnetic axis and the angle between the magnetic axis and the electric current becomes negative, Lorentz force will result, but in the opposite direction. And that's why when I started earlier, I said, if the south magnetic pole moves from the north geographical pole to the south geographical pole, the rotation of the planet will be reversed and sun will shine every day from the west.
I have a question at this point. With the magnetic pole moving, is the second scenario there, the day is 30 hours, is, in your opinion, is that something that we're beginning to move towards?
Yes, I believe there is a cycle, and I try in the next coming pages. I tried to go through history books and history citations to find out the cycle of repetition and the extent of the change. But yes, I do believe we are moving towards such a change, where the planet rotation will slow down. It could even stop or tilt in reverse for a couple of days. But I'll explain that in the next slides.
Many of our guests also agree with you on that point also. You are not alone, sir.
Gives me oxygen to move on.
Yes, it is. Don't think that you're giving us something that the majority of our audience has not heard before. This is something that all of us are understanding, and you are explaining it in a new way to the audience. And I am going to, at this point, I am going to stop and let you catch your breath for a second and tell the audience that what you need to do is you need to go to Amazon.com and you need to get a copy of this gentleman's book. And we will put a link up here on the show page so that, we'll send out a link with our email newsletter too, so that you can go and purchase the gentleman's book and gain a much better understanding of what we are talking about here. And you need to spread this to everybody that you know.
Thank you, Bill. The next slide, slide 18, when the Earth stopped spinning. Actually, the best history books I found are theology books, so the Old Testament, the New Testament, the Quran. In all theology books, there is a section about history, there's a section about worship rules, what have you, there's a section about values, and so on. I'm only referring to the holy books as reference for history. And foreseeing of events. So when I looked at the Old Testament, I found a mention to two situations where the planet stopped spinning. One at the Exodus of the Israelites from Egypt, where darkness overruled Egypt for 3 days in a row, complete darkness, thick darkness. And 50 or 45 years later, when Joshua prayed to God to make the sun stand still until he's done with his battle, and the sun and the moon stood still. In fact, Earth stood still at that time too. How did this happen? I look into page 19 and I try to understand. In fact, I go to history to establish a big debate about where the Israelites crossed the sea. Was it at the Red Sea or the Sea of Reeds? And I looked into many history books in this regard, and I found, and this perhaps new, I came up with this analysis that the Israelites used to live in Avaris, what we call Mansoura today, in the delta of Egypt. And they have noticed or watched something in the sky, a sign in the sky, that made them decide this is the time to move out. It was a pillar of clouds in daylight and a pillar of fire at night. Could be a planetoid, could be a small planet. Something is cutting the sky. And they move towards northwest. There is a village called Rosetta. When they decided that the sign has moved eastward, and therefore they turned eastward, and this is a 50-kilometer strip on which they have the Mediterranean on the northern side and the Lake Borealis, or Reed Sea, or Sea of Reeds, on the southern side or right-hand side, until they reached a crossing or a canal that connects the lake to the sea. At that time, the Santorini eruption caused the water to recede and the canal to be exposed, so they were able to cross on foot. I visited the place, and immediately as you cross this canal, there is a hill 14 to 15 meters high. It's like 50 feet high. And they were moving 12 tribes up to this hill. The Santorini eruption went 48 kilometers up in the sky, and it pulled a lot of water with it. And then it fell down. Water caused tsunami, and this tsunami had overwhelmed the ridge, the 50-kilometer ridge, and the army that were in pursuit to the Israelites were perished.
Yes. To interrupt you just for a second, we have several guests on the show on a frequent basis. Lynn Marzulli and John DiNardo come to mind, and you are saying the exact same things that they have found from their independent research. And I find it fascinating that you have actually been to the spot. So you're giving us more of an eyewitness account of what the area physically looks like. I find this to be highly fascinating, and if 3 independent researchers come up with the same conclusion, I find that it is much more likely to be in fact the correct conclusion.
Thank you. Then I move into what could the sight from the sky be? What could it be? And I move to slide 20. I know time is running.
That's okay. If we run out of time, we can have you back on. We can do a show on Saturday evening too, if you want to. If that's entirely up to you. We want to make sure that we cover all the information that you have, so that the information is complete and correct for everybody. And if it takes a second show, it takes a second show. That is fine with us. If you have the time, we have the time.
Thank you. This slide contains 3 verses. One from the Old Testament, one from the New Testament, and one from Quran.
Okay, let me see if I can zoom in on this so that the viewing audience can see it a little bit better. Let me see. Okay, that I think they should be able to read that very well. We're looking at the earlier sign from the sky was told / foretold. And go ahead and you can go ahead and continue.
Abraham was trying to find God. He saw at thick, dark night, he saw a planet. And he said, could that be God? But the planet was gone, the moon emerged. And he said, no, it is the moon, it must be God. And the moon disappeared and the sun came up. And he said, well, the sun is stronger, mightier. the sun must be God.
Mm-hmm.
But when the sun disappeared, he said, no, no, God is above all. And I wondered how a man living in a desert, a Bedouin, let's say, can see a planet as visible as he's seeing the moon or the sun, unless it is in proximity and it is as visible as the moon and the sun. Where is this planet coming from, and what is that planet? And then I moved to Isaiah, 7th century BC, in his words that the sun will arise from the west. And then I moved to John the Divine in the New Testament, in his revelation words. The sun became black and the moon became as blood. And I think, could it be that the moon eclipsed the sun, and then a planet appeared by that has a reddish color or a red color? So when I looked into the three verses from three different citations, I became more convinced that there is an object that comes on a frequency to the solar system that becomes so visible. And since it's another planet or planetoid and has obviously magnetic pole, such a magnetic pole will cause our inner core to tilt and to wander, and to cause the increase in earthquakes as it is tilting, the move of the magnetic pole from Canada towards Siberia, and all the changes that we are observing that are connected as cause and effect to one another. So I said, let me go to the next slide, 21, and try to reflect on the timeline here to come close to a frequency of or cycle of repetition.
And our viewers, this is called As We Reflect on the Timeline, our regular viewers will be very, very familiar with this timeline. We speak about this a lot.
Now, I'll explain something new here. When I said, when we discussed Moses and Joshua, Earth stopped twice in a period of 40 to 50 years, but that was 1500 BC.
Right.
What about Abraham? He saw a planet as clear as, in a dark sky, as clear as the moon and the sun. When that happened, historians are referring to Abraham as 500 years only difference from Moses. He predates Moses by 500 years. Most historians are claiming this, and I think they are incorrect.
Yes.
You see, the reason is in the Old Testament and in the Quran, there are mention that Abraham was the first male to be circumcised. And it's both Jews and Muslims believe in this as a fact. Now, there are papers issued by the Imperial Surgical Society, Bristol actually, in 1905 and 1908. These papers are available on the internet in the old publication that was produced at the time. And they found out that the process of circumcision is scripted on Egyptian temples 2,000 years before Moses, and they found two mummies that were circumcised 3,000 years before Moses. So, as Abraham is believed to be the first man to be circumcised, it's only logical that It could be 3,200, 3,400, or 3,500 years before Moses.
I'm going to go with 3,500 years.
Yeah, and funny enough, and we'll come to that, people used to live for 300 years, 1,000 years, 900 years. How did this happen? I'll come to that, but this could explain why scientists, historians, believe that Abraham predates Moses with only 500 years. Probably they assumed that the life expectancy is 80 years, but it was much, much longer life expectancy. And this confirms that Abraham predates Moses with more than 3,000 years. And then we all know about the Great Deluge, the Great Flood. And most scientists are saying this is 10,000 years ago or something.
Mm-hmm.
Those are three events where changes were observed, or big catastrophes took place, like sudden melt of ice caps. Now, at this point in time, we have two revelations. One is by Isaiah, the second, St. John the Divine. And if the cycle is 3,500 or 3,600, then I think we are due for another encounter.
You are, I believe, exactly correct.
Let's move on. So, where is this coming from? And how can we explain a cycle of 3,500, but yet 1,040 or 50 years? Moses and Joshua. And the only explanation for this is that the planetoid, or the planet that is visiting the solar system, moves in elliptic path, and it crosses the solar system twice, once in a longer cycle that is 3,500 years, and once in a shorter cycle that is 40 or 50 years. Now, on the solar system, we have 8 planets plus 3 dwarf planets. Pluto is a dwarf planet. Also Eris and Makemake, which were discovered about 7 years ago, beyond Pluto. And both have moons rotating around them. So if we include planets and dwarf planets, currently scientists are confirming 11 planets in the solar system. So could that be the 12th planet? And coming to visit us very, very soon. But when it does, it will be twice in 40 to 50 years. If I move to slide 23, then I explain on slide 23 and 24 what does that planet cause. First, due to the magnetic pull of the new planet, Earth's magnetic force lines could be further protruded or bulged while traveling around the Earth between its two magnetic poles. This makes scientists measuring the intensity of the magnetic field from New York or Paris or London think it is getting weaker, but it is not. It is only going deeper into space. Then the distance between the lines are getting wider, a little bit wider. But if you go to the Antarctic, where the magnetic force emerges on the surface, and measure the strength of the magnetic field, you will find it intact. The core inside the planet has not weakened. It's only the lines, the force lines, are getting deeper into space before tilting back. and that makes them appear to be weak, but they are not.
Yes.
And then on the second, please go ahead. You have a question?
No, just a comment. I agree with you. You are again hitting exactly on what a lot of our guests also say. You're getting into this more scientifically than many other people do, and I give you extremely high credit for that. You have you're doing a magnificent job.
Thank you. On the following slide, not only the magnetic strength of that visiting planet pulls our magnetic force lines, but it also causes the core to tilt. In the drawing, I point out that the north pole, north magnetic pole of our planet and the south magnetic pole of the visiting planet or 12th planet will try to meet each other. Of course, the magnetic lines are doing this tilting, and that explains why the core is tilting, why the magnetic pole is moving, and why earthquakes are on the increase. As it comes closer, it will move faster. And as mentioned earlier, the pace of movement have quadrupled in the past few years.
Yes. Yes, it is definitely getting closer.
And then I'm saying that almost the last slide is, what if the inner core, the magnet, settles so that its poles are in India and Brazil? It's a scenario. I cannot tell for sure. Of course, if this happens, then the axes shift between the magnetic field and the electric current in the outer core will get much smaller. So the Lorentz force produced along the perimeter of the outer core will be less. So the day is longer, as well as the temperature belts. So the ice caps will melt from the Antarctic and the Arctic Circle, and they will rebuild where the magnetic pole will finally reside, whether India, Brazil, or Mongolia and Peru, or west of Peru. It all depends. Of course, the meteorological and precipitation will vary greatly at this point in time.
Let me, this is extremely interesting, and I believe that we have come to the crux of the conversation. The new equator, or the new, I guess we can call it the new equator.
Magnetic.
Yeah, the new magnetic pole will be in those areas that you mentioned. Where do you believe the new Arctic areas will be?
Where the magnetic poles finally reside is where the ice cap will be building.
And geographically, where do you think that will be?
No change at all. Geographically, will only change due to some earthquakes.
Okay.
But the rotation axis remains the same. Geo more or less remain the same. But, if you have earthquakes, Red Sea gets wider, the Hormuz Straits is closed. These things are small geographical changes. But the major change is in the temperature belts. The temperature belts form in rings centered by the ice caps. And the ice cap is where the magnetic pole resides. And as we saw earlier, it is melting from Canada and building towards Siberia. when the magnetic pole moves to Mongolia or to India or what have you, wherever it will settles is where ice will be formed again, slowly, depending on the precipitation.
Okay. So,
but more importantly, is that the aging process of the human species will be different, will be slower. And this, I noticed that the many research on this, the pineal gland is the responsible on the and controls the biorhythms of the body, and it is the biological clock that determines the aging process. This pineal gland is triggered by the succession of day and night. So if such a succession is slower, then it explains how Noah and the people around that time lived to 900 years, 1,000 years, in good health, of course.
Because the days were longer?
The days were longer, and you see, let me explain the following, very, very simple.
Okay.
The Earth rotates around the Sun in one solar year.
Mm-hmm.
Currently, the solar year is 365 days. The human body, let's say, lives on average 80 years. This means about 30,000 days. So currently, 30,000 days is 80 solar years. Am I right?
Right.
So if in the future, solar year, let's say 36 days, instead of, to make it simple, it's 365. Okay? And if this body lives 30,000 days, so a simple math, divide 30,000 days by 30 days in a solar year, you end up with 1,000 years. So 1,000 solar year becomes the average age of human species at this point in time.
That is a extremely logical deduction.
And this may impact the science of space travel, because if the pineal gland, the aging process, is a function of succession of day and night, and if space travel, there is no succession of day and night, I wonder if this means eternity, but I'm not a medical doctor here. I'm only raising a question.
That's that is also a very, very interesting concept. That is, I wonder if they're doing any experimentation with that on the space station.
More research. Now the final slide is, what do we do then in this case? If this is a cycle that we cannot control, what can we do? If today the precipitation map is producing fertile water resources, abundance of water in some parts of the world, and drought in other parts, and if tomorrow the water shifts, you know, in the West today you have, for instance, technology, best practice, you have water, you have resources, you have capital, whereas in the Sahara, the desert, you have none of the above. Tomorrow you have water in the Sahara, and you have shortage of water, let's say in Europe. Then is there a transformation plan that will bring the expertise, knowledge, best practice, skills, resources where the water is? I mean, you don't have to execute it today, but at least have it ready so that if this happens, you just execute it. Transfer of skills, expertise, equipment, alignment of migration rules, transfer of capital, all this. Energy, same thing. You now have 10% of the energy is produced by hydro dams.
Right.
If water, it's different. These hydro dams will sit idle. What about, in my book, I put it that nuclear power plants are very good, provided you keep them away from the coastline because of tsunami. And this I published 2 years ago, and look what happened to Japan.
Right. And that's also something we have discussed in depth on the show, is the situation on the Canary Islands. And if the side of the Canary Islands on that volcano slides into the ocean, you're looking at a mega tsunami. And our estimation would be that you would have a tsunami from the Maritimes all the way down to the bottom of South America. And I think a conservative estimate would be between 50 and 75 million people dead.
Coastline is dangerous, very, very dangerous. You have seismic belts along the Mediterranean. So the delta of Egypt is a coast, for instance, as well as Greece, Turkey, Algeria, Morocco. You have along the Mediterranean. Wherever you have a fault line, there's a big risk. And if you have a 5-meter wave coming across, close to shore, that could reach 100, 200 meters above.
Yes.
You just multiply by 20, a factor of 20 or more. And this is devastating. So the code of infrastructure also should be changed. You stay away from the coast by 8 to 20 kilometers, or at 100, 150 meters above sea level, to be on the safe side.
Or as far inland as you can possibly get.
Yeah, I said 8 to 20 kilometers inland. And so you keep away from such tsunamis.
The interesting point in all of this, and again, we have discussed this in depth on the show, and this is what you're bringing to the table here are some entirely new viewpoints. Here in the United States, and I don't know if you have access to this information or if you know it, the United States government is moving many departments to the geographic center of the continent. They have moved our revenue service, parts of our space service, our defense, to Denver, Colorado, which I'm sure you know is high above sea level. And it's essentially the geographic center of the country. And they're moving intelligence services, military services. They're moving more and more services right to the center of the continent. So it seems that they are in fact preparing for something.
I add to this that I believe for welfare and benefit of all people, there could be a setup where the United Nations, for instance, is focusing only, 100% focused to develop transformation policies. And for countries of the world to own and become lead countries are transformation of certain industries from the current situation to the to-be situation. And then NGOs all over the planet will facilitate the speed up and delivery of those plans, either before the event or during the event or after the event.
And what exactly are NGOs?
NGO is non-government organizations.
Okay.
Normally non-for-profit. They are running on the human capacity and the human intelligence of communities.
Okay.
And they run for no profit, but to benefit the community. We have to have distributed food stores, for instance, because it may happen that the transformation means or ports or what have you will be cut off. So we have to have enough grains or food for small communities. And many of these strategies have to be developed across all industries, whether agriculture, energy, infrastructure, civil order, capital markets, wealth management, health, and so on. Today, if you have an interruption in information systems, can you open law books or textbooks and find answers to questions? If you are a policeman and you are relying on a computer to do your work, you cannot possibly go back to a mug book. You don't know it. You don't know how to do it. The current generation is way from manual work and manual access. So if, as that planet comes closer, the magnetic fields gets weaker, you will have disruption not only on satellites, as we had earlier in the program, but also on electronic gadgets all over the place, in our cars, in our computers, in our everyday life equipment. They may be haywired and stop to function. Can you manage your life in a manual way and run your job in a manual way?
I would say for 90% of the people now, no. We rely far too much on the information technologies.
Then we have to plan, if this happens, how can we cope up and still provide a minimum level of service in each aspect or angle of industry or life?
What's your suggestion for that?
As I mentioned, United Nations, for me, is an entity that could focus in delivering of rules, guidelines, policies, under which countries will own the development of strategies and delivery of such strategies to transform industries and sub-industries across the planet. Treat the planet as a company with different departments. Put rules, put leadership, ownership, put plans, and go and execute. Of course, you have to reroute funds and reprioritize funds towards this goal. But it only needs us to agree that this is the coming and this is happening, and therefore there's no escape. We have to do it. And along the history, human nature is always under threat. People get together, work together, and work together. What I'm saying is, let us be prepared so that the casualties and calamities are minimized and recovery is faster.
Do you think that the UN, the way it's currently structured, is even capable of doing something like that with all of the politics, geopolitics, and all of the infighting and backstabbing and everything that human beings do?
Once we agree that there is a threat, all that will drop. The UN has the infrastructure of getting all the leaders of the world.
This is true.
Than anyone else. All that it takes is we agree that this is happening, and therefore there is no escape. We have to act as one.
One thing, and I don't know if you see it over in Dubai or not. I don't know if you see it in that geographic area of the world at this point. But we here in the Western world, and I believe also in in Asia, and I know South America also, we are seeing a definite movement by the existing governments and what we call the powers that be to begin protecting themselves without informing the populace at large about the coming danger. And we believe, the people on my staff and a lot of our guests, we believe that the governments already know that something is happening, and they appear to be pre-positioning themselves for the government entities to survive rather than the population themselves.
I don't know. I can't tell because you needed facts, you needed evidence. You mentioned that you're watching the relocation of government bodies and so on.
Yes.
This is an evidence.
Yes.
You need many of these evidences to establish the fact. But if there is such a preparation, it means we have a pilot that is successfully running. And we can expand on this pilot. Let me think positively. We can expand on this pilot to understand, in any pilot you have wrongdoings, but to understand, to learn from the pilot and replicate across all other industries, all other services, all other communities. I would say it's good that there is such a pilot in place already. We can learn from it, we can replicate it.
Do you think the way humans are? I mean, look at the way that all of the wars, all of the fighting, and everything else, and the evidence of this thing coming in is it's so darned apparent. It's unbelievable. I mean, look at all the evidence in the Bible, the evidence in the Quran, like you were mentioning, and the historical evidence in other books, other writings, other traditions, in other cultures. I mean, it's obvious that this is happening, and yet we continue to bicker and fight and everything else. And I suspect that until that red planet is visible in the sky to everybody, everybody's going to completely ignore the information. And my question to you is, what methodologies can we use to convince these people, to show them the evidence? Because the evidence is there.
Keep what you're doing.
Or is that really?
Keep what you're doing, yes. Keep spreading the information, spreading the news as much as you can. Run 48 hours a day if you can.
Well, what I do is we run the audio stream 24 hours a day right here from in my home. We run the video stream. This show is going to repeat probably for close to 100 hours. It will be on our YouTube channel. And for those of you that haven't been paying attention to the YouTube channel, we have quadrupled our audience share in the past month. More and more people are coming on board. And we are preparing to launch a brand new methodology on the internet, I believe, to getting this word out in an adult manner rather than the bickering, backstabbing manner that we normally see of getting this information out on the internet. And I appreciate your words about keeping on, and I'm going to say you keep on too. You need to get on as many media sources as you possibly can, I believe.
I'll do my best. I'm very much convinced of the findings, and I wish to share it with every soul, every person on the planet as much as I can.
Yes, we are, even though we're on opposite sides of the planet, I believe, sir, that we are both on the exact same page. Absolutely.
Thank you again for giving us this opportunity, and let's keep in touch.
Yes, we will do that. We have, folks, we have reached the end of the show. We have actually, once again, gone over on our time. Let me see how far over we are. We're 20 minutes over on our 2-hour show, but since it's my show and my network, I can do whatever I want to. So we are going to thank our guest for coming on tonight. We are going to keep in touch with him, and again, I advise everybody to purchase his book and begin reading and giving it away for gifts, birthday gifts, Christmas presents, what holidays, whatever kind of holiday you want. And I thank you for coming on the show. We really appreciate it. And I will send you some email links about where the MP3 is so that you can download that and spread it amongst your contacts. And there we go, folks. We are going to say goodbye to our guest and end the show now. And we are going to get this up on YouTube as quickly as we can and get the MP3 up on the internet as quick as we can. So until we see you again, this is Bill Zam. Thank you for watching Surrounded by Idiots, and we appreciate you tuning in. And there